It is our pleasure to present Form 2 work as tested in 2022 KCSE Chemistry Paper 1. Looking at Paper 1 for the year 2022, we realize that Form 2 content was tested in 5 questions. That is question 1, 2, 9, 13 Part A, and 15. These questions had a total of 13 marks, which translates to 16.25% of the total score in Chemistry Paper 1 for the year. Welcome and stay on until the end. Let's begin with looking at the expected responses to question number 1. Question 1, Part A. We are asked to state one property that can be used to distinguish between a proton and a neutron. Here, a candidate would quickly think about charge. Charge is actually a property that can be used to differentiate between the two particles. We would go ahead and explain that a proton has a positive charge. A proton has a positive charge while a neutron has no charge. That would be very, very appropriate response to our question 1, Part A. We are then told in Part B that an ion of element Y has the formula mass number 40, atomic number 20, and a charge of 2 plus or positive 2. From here, we realize that for the element Y, atomic number is 20, and for that matter, element Y would have a configuration of 2882. But it forms an ion through loss of 2 outermost electrons. So then in Part 1, we are asked to write the electron arrangement of the ion. For that matter, after losing the 2 outer electrons, the ion now would have a configuration of 288. Next, we are asked to identify the group and period in the periodic table in which the element, not the ion but the element. So the element has a configuration of 2882. For that matter, group would be shown by the number of electrons on the outermost shell, and that is group 2. For the period, we count the number of shells, and here we have 1, 2, 3, 4. For that matter, element Y belongs to period 4. We look at the next question from Form 2 work, and that is question number 2. Question 2, Part A. We are told to complete Table 1 by writing the formula and naming the structures of the chlorides of the element captured in the table. So for sodium, the formula of the chloride is sodium chloride. The structure here is giant ionic because sodium chloride actually is formed when a metal sodium is bonded to a non-metal chlorine. So the bond here is expected to be ionic bond or electrovalent bond, and the structure will be giant ionic bond. For magnesium chloride, the formula becomes MgCl2, and just like sodium chloride, the chloride of magnesium also has a giant ionic structure. For silicon, we have silicon 4 chloride, and because it's made of 2 non-metals, we expect a simple molecular structure. Phosphorus, we have phosphorus 3 chloride, or it may also form phosphorus 5 chloride. Again here, phosphorus and chlorine are both non-metals, so the structure is still simple molecular. As easy as that for 2 marks for the table. Then part B, we are told to select an acidic chloride from the table and write the equation for its reaction with water. According to our table, acidic chlorides are 3. We have phosphorus 3 chloride, phosphorus 5 chloride, and silicon 4 chloride. So a student could go for any of those 3 and write the equation for their reactions with water. But for purposes of this demonstration, we shall write for all of them, beginning with our phosphorus 3 chloride. So it is a liquid being reacted with water. We shall form phosphoric 3 acid with the formula H3PO3, and this would be accompanied by hydrogen chloride or hydrochloric acid. We would balance with a 3 on water and a 3 on hydrochloric acid. We then go on to write the equation for the next acidic chloride, and that is phosphoric 5 chloride. Reacted with water, we would now form phosphoric 5 acid, that is H3PO4 aqueous, and again we shall have some hydrochloric acid being formed as well. This time round we balance with a 4 on water and a 5 on hydrochloric acid. The last acidic chloride would be that of silicon 4 chloride. This would react with water to form silicon 4 oxide, and we shall as well get hydrochloric acid. So we balance with a 2 on water and a 4 on hydrochloric acid. A candidate would decide to go for any of the 3 equations. We move on to question number 9. Question 9, part A, is telling us that water reacts with hydrogen ions, and we are supposed to write the formula of the product formed. This is simply the hydroxonium ion, H3O+. Then we are also asked to name the type of bond. So when water is reacting with hydrogen ions come with no pair of electrons. The pair of electrons that it uses to bond with water are kind of donated fully by water. For that matter, the bond is dative, or we also call it coordinate, just like what happens in ammonium ion. Question 9, part B, is telling us that the melting point of iodine is higher than that of chlorine. We are supposed to explain. So we know that iodine molecules are bigger than chlorine molecules, and therefore the van der Waals forces are stronger in iodine. So the expected answer here was supposed to be that iodine has larger molecular mass. Iodine has larger molecular mass because the molecules are also larger, thus stronger van der Waals forces of attraction. Van der Waals forces of attraction than chlorine, which has smaller mass. Instead of talking about molecular mass, a candidate would think in terms of size of molecules, which is also correct. Let's move on to question number 13, part A, which again was borrowed from Form 2 syllabus. Carbon exhibits different boiling points, so we are told to explain. So here we all know that carbon exists in different crystalline forms, what we normally call allotropes. So carbon exists in different crystalline forms in the same physical state. That is actually the meaning of allotropes. So carbon exists in different crystalline forms in the same physical state, hence different boiling points, because the allotropes have different structures. That would be the answer to question number 13, part A. Part B of the same question was not from Form 2. We then end our short video by looking at question number 15, which again came from Form 2 syllabus. Two allotropes of carbon are graphite and diamond. In part A, we are asked to explain why the density of diamond is higher than that of graphite. The reason here is that atoms of diamond are closely packed. Atoms of diamond are closely packed by strong covalent bonds with smaller volume. So if they are closely packed, the volume is smaller, hence higher density. That is what makes diamond to have a higher density than graphite. So we continue to explain what goes on in graphite, that while graphite atoms on the other hand are held by weak van der Waals forces. Weak van der Waals forces with larger volume, hence less density. We continue to part B, and we are told to give one use of the allotropes, and then we were supposed to relate the use to the properties of the allotrope. We begin with graphite. The first use can be as lubricant. We can also use graphite to make pencil tips, what we normally call pencil lead, and graphite can also act as an electrolyte, an electrode. So for the property, if a candidate went for lubricant, the property would be that graphite is slippery. If you went for the use of making pencil tips, then we can say that graphite is soft. And as an electrode, we use it because it conducts electricity. For diamond, the uses would be as follows. We can use diamond to make drill bits. We can also use it as jewelry. Now, for the property, if a candidate went for the use of making drill bits, we would say that diamond is hard or abrasive. And for those who went for the use of diamond as jewelry, we would say that it is shiny or it has luster. For the half mark given for that section. With that, we have come to the end of the video where we have reviewed 2022 KCSE Chemistry Paper 1. Our interest has been the contribution of Form 2 syllabus to the overall performance in this paper. We wish you all the best, and we ask that you keep it here for more reviews.